In this lesson, you'll learn about systems software, particularly the functions of an operating system. But before you do, let's briefly consider what is software. Software is the programs and data needed by a computer to do pretty much anything. It's the instructions and any other information a computer must have to make it work. Software is computer code and binary encoded data. Unlike hardware, which is all the physical parts of a computer, software is something that you can't touch. But without software, your hardware is useless. There are two main categories of software: application software, more simply known as applications or apps, and systems software, which we're going to take a closer look at in a moment. Different applications allow the computer to do all kinds of tasks, like writing an essay, performing calculations, creating images, editing sound recordings, surfing the web, writing programs, or playing a game. The list just keeps getting bigger. Most of the software we interact with falls into the category of applications. Systems software, on the other hand, includes the programs required to keep a computer running and to help maintain it. There are three types of systems software: operating systems, device drivers, and utility programs. Well-known operating systems include Microsoft Windows, Apple Mac OS, Unix, Linux, Google Android, Apple iOS, Google Chrome OS, Amazon Fire, and many more. Every computer system, including phones, tablets, gaming consoles, and all manner of smart devices, has an operating system. The purpose of an operating system is to allow applications, and therefore the user, to interact with the computer's central processing unit. The operating system also allows hardware components, such as input and output devices and storage devices, to interact with the CPU. In fact, pretty much all access to the CPU has to go through the operating system. Let's take a closer look. The main functions of an operating system include to provide a user interface, memory management, process scheduling, also known as multitasking, device management, user management and security, and file management. The first function of an operating system is to provide a user interface. A user interface allows the user to interact with the computer and its applications. Depending on the operating system, it might be a graphical user interface, or GUI for short. Graphical user interfaces include windows, icons, menus, and pointers. WIMP for short. Perhaps the most well-known GUI for a personal computer is the one that comes with Microsoft Windows, and there are plenty of lookalikes. Graphical user interfaces are nice to look at and easy to use, but those benefits come at a price. They require lots of resources like CPU time and computer memory to perform well, which means that there is less available for other tasks. We say that they are resource intensive. Some user interfaces are known as command line interfaces. The user interacts with the command line interface by typing text commands only. Feedback from the command line interface is also text only. This type of user interface tends to be very plain looking, and you have to learn a lot of commands to use it proficiently. Not only that, but you really need to know what you're doing, because some commands can be very destructive indeed. But on the upside, a command line interface is a lot less demanding on the computer's resources, and once you've learned how to use one, it can be very quick and responsive. Some modern user interfaces also include voice control, which allows you to talk to an operating system. And these days it goes well beyond a few verbal commands. You can literally hold a conversation with a computer. Gestural control, in which you can tell the computer what you want it to do with physical gestures like moving your hands. Some systems can even read your facial expressions. And then there are brain-computer interfaces, which allow you to control a computer simply by thinking. You can imagine, as artificial intelligence continues to advance at an extraordinary rate, one day communicating with a computer will be as good as telepathic. The second function of an operating system is to manage the computer's main memory, that is, the random access memory, or RAM for short. When you launch an application by clicking a menu item, or an icon, or indeed by typing a command, the program code is copied from secondary storage, such as your hard drive or SSD, and loaded into the RAM. The application is now said to be running, and its programs can now be executed by the CPU. Part of the operating system itself is always running. A set of programs called the kernel are responsible for crucial functions like memory management and multitasking, so these were loaded from secondary storage into the RAM when the computer started up. Whenever you launch an application, it's up to the operating system to work out how much space it will need in the RAM, and exactly where in the RAM it should go. The operating system will also make sure that the running programs don't intrude on each other's memory space. Data that are currently being used are also allocated memory space. If you're running a word processor, for example, and you create a new document, the operating system will find a place for it somewhere in the RAM. And of course, if you have multiple files open at once, they will all need to be allocated memory space. The operating system keeps track of which files belong to which applications. When you close a file or exit an application, the operating system will ensure that the memory they were using is freed up and made available for something else. When the RAM is getting particularly full and you try to launch another program, there may not be enough room for it. Arguably, it's time to get some more memory for your computer, or to stop trying to do too much at once. But until you do, the operating system has a trick up its sleeve. If an application is running, but the user hasn't interacted with it for a while, some or all of its programs will be moved automatically out of the RAM to a special reserved area of secondary storage called swap space. To be clear, this is not the same as closing the application down. It is simply paused temporarily so that something else can take its place in memory. When that paused application is needed again, the operating system will very quickly swap it back into the RAM so it can pick up from where it left off. This is much quicker than having to reload it from scratch. Supplementing the RAM with secondary storage like this is called virtual memory. The user is generally unaware that this kind of memory juggling is going on behind the scenes, unless it's happening a lot. Secondary storage is much slower than RAM, particularly if you have a magnetic hard drive rather than a solid-state drive. Excessive swapping can result in a problem called disk threshing, and it can make the computer feel very slow indeed. In summary, running programs are allocated memory space by the operating system. Data that are currently being used are also allocated memory space by the operating system. If you have a file open, it's occupying space too. When you close a document or exit an application, the operating system will ensure that the memory is freed up. When the RAM is getting particularly full, it can be supplemented with virtual memory. The third function of an operating system is multitasking. Once a program has been loaded from secondary storage into the RAM, it's ready to run, and it's known as a process or a task. A single application like a spreadsheet, for example, usually consists of several different programs and will therefore give rise to several tasks on its own. Here we have a single core processor, which can execute only one program instruction at a time. But the operating system can make it appear as though lots of tasks are running simultaneously by controlling their access to the CPU. This is called multiprocessing or multitasking. Each task is given a short amount of time with the CPU, about 1/100th of a second, before it's paused and another task takes a turn. 1/100th of a second might not sound like very much, but it's enough to execute millions of program instructions. A paused task is moved to the back of the scheduling queue, but it will soon get another turn, then another and another. The switching happens so quickly that as far as the user can tell, several applications are running simultaneously. This type of multitasking is known as round-robin scheduling or time slicing. Some tasks are more important than others, so they get more time with the CPU. Programs that are part of the operating system, for example, have a higher priority. If an application is idle, then of course it doesn't require the CPU's attention at all. However, there is almost always something running if the computer is on. Urgent tasks can also interrupt normal scheduling and demand immediate access to the CPU. For example, if there's been a power failure and files need to be saved immediately. A CPU with multiple cores can really run programs simultaneously, rather than the operating system having to fake it. But those programs must have been designed to work on a multi-core processor. Summarising, even with a single-core CPU, several applications can appear to run simultaneously. The operating system performs round-robin scheduling, in which each task is allocated time slots with the CPU. Some tasks have higher priorities than others, so get bigger time slices. And an urgent process can interrupt normal scheduling. Multi-core processors allow for true parallelism, if the programs involved have been written to take advantage of this. The fourth function of an operating system is device management. It ensures devices like the keyboard, mouse, monitor, speakers, hard drive, network interface controller, and many others are available when you need them. For example, when you're typing text, saving a file, or watching a video. The operating system relies on device drivers to achieve this. Every device has its own driver. A device driver is a program that controls the input and output operations of a specific piece of hardware. It also enables movement of data between the device and the operating system, which in turn allows running applications to access the hardware. The operating system itself comes with lots of drivers to control a wide range of devices, so you could say that the device drivers are part of the operating system. However, some devices will look for specifically written drivers when they're connected for the first time. For example, if you connect a new gaming keyboard to your computer, or if you fit a new state-of-the-art GPU, the new device will probably request a driver that has been supplied by the hardware manufacturer. The operating system will ensure that the driver is installed properly and that it's updated when new versions become available. Device drivers are programs, so, just like other programs, they need to be allocated memory space and CPU time when they're running. The operating system takes care of this. Many drivers are automatically loaded into the RAM when the computer starts up. Here's a recap. It's the job of the operating system to control the computer's hardware. Device drivers handle input and output operations. They allow devices and the operating system to exchange data. Device drivers are installed and updated by the operating system, and the operating system controls their access to memory and the CPU, just like every other program. The fifth function of an operating system is to manage users and provide security. This means controlling who can use the computer and what they can do with it. One feature of user management is that different people can share the same computer, but they can each have their own personalised user interface. That is, they can each have their own user profile. For example, each user can have their own desktop wallpaper, their own colour scheme, or their own set of desktop shortcuts and menu items. Users can also choose from a range of accessibility options such as high contrast colours or bigger icons and pointers, and left-handed users can even reassign their mouse buttons. On a Windows computer, usernames and passwords are stored in a special database called the Security Accounts Manager, SAM for short. Each user also has a special configuration file called NTUSER.DAT, which is where their personalised settings are stored. This file is located on the C drive in a folder called Users. When you log on, the operating system checks the SAM to make sure you've entered the correct password for your username. This is called authentication. If they match, NTUSER.DAT is then used to apply your personal settings. As well as a customised user interface, each user can have their own documents folder in which to store their own private files. Normally, you can't see another user's documents unless you know their password, or unless you've been set up as an administrator. Administrators have much more control over the computer and other users. If your computer is connected to a network, you may have the benefit of a roaming user profile. This means that your personalised user interface will be available wherever you log on. When you log off a networked computer, any changes you've made to your settings are saved in the file NTUSER.DAT, and this is automatically copied to a server. When you log on somewhere else, the server checks your username and password, then your settings file is copied from the server and applied to that computer. So, as you move around the network from computer to computer, your profile effectively follows you. The operating system on each computer and on the server is responsible for managing roaming user profiles. And a server operating system can do much more. For example, it can allow different users different levels of access to shared resources. One user might be able to save and modify files in a particular folder on the server, while other users are only allowed to read and copy those files but not change them. Some users might be able to access a particular shared printer, whereas other users may have no access at all. And some users can be given permission to install new software onto the computers and even set up new users, whereas other users will have a much more limited experience. To recap, the operating system controls who can access a computer and what they can do with the computer. Users must log on with a username and, usually, a password. This is called authentication. There can be multiple user profiles on a single computer, so that different users can have their own personal settings. An operating system might also support roaming user profiles on a network, so that users can move comfortably between computers. A server operating system controls users' access to shared resources such as folders and printers. The final function of an operating system is file management. Operating systems give users and applications easy access to secondary storage. This is made possible with files and folders. There are lots of different types of file, depending on the applications used to create them. For example, there are text documents, spreadsheets, presentations, images, movies, audio files, program files, and many, many more. The operating system can identify a file type by its file name extension. So when you double-click a file, the operating system can use the file name extension to decide which application it should use to open it. Most modern operating systems include a file explorer, an application that lets you create folders to save your files in. You can also create folders inside folders, so you can organise your work in a hierarchical file system. A file explorer allows you to copy, move, rename, and delete files and folders. And if you're sharing a computer, you can fine-tune the access that other users have to individual files or the entire contents of a folder. But it's worth noting that not everything is as it seems. The way files are stored physically on secondary storage is rather different to the way it's made to look by the operating system. And exactly how depends very much on the type of secondary storage medium, be it magnetic, optical, or solid state. The operating system allows us to visualize data handling tasks as if we were working with a paper-based filing system, regardless of how the binary data are actually encoded at the hardware level. This means we can work more intuitively than if we had to think about what was really going on behind the scenes. But that, as they say, is another story. To summarise, the operating system provides easy access to secondary storage for applications and ultimately for users. Folders and subfolders allow for the hierarchical organisation of files. A File Explorer application displays detailed information about files and provides file handling operations such as move, copy, rename and delete. File and folder permissions allow for fine control over shared access to files and folders. In conclusion, an operating system is a type of systems software, whose purpose is to allow applications, and therefore the user, to interact with the computer's hardware. A computer is useless without one. An operating system is a collection of programs, some of which manage the memory, and some of which allow multitasking. Device drivers allow various hardware components to communicate with the CPU. Other operating system programs provide secure access to the computer and to the files and folders stored on it. Modern operating systems also come with a range of utility programs to help maintain the computer. You can find out more about these in another lesson.